Hi, my name is Leandro Facchinetti, and let's write some code together, shall we? What we have on the menu today is two things. We are going to finish our circular buffers and then finish the RMS computation. In case you just landed here, we are writing a library to help other people develop better looking and hopefully easier to develop JSFX, which are real-time audio processing things in Reaper. So circular buffers are this data structure that store a signal and you can just push new samples into the signal and you can recollect samples from the past up to a certain point, up to a certain size. And this is a data structure that will have three fields: the size, which is the maximum amount of samples that you can store in the circular buffer, the current index of the read and write pointer into this circular buffer, and then the data that I'm calling it data, but I think I'm going to call it signal. A signal is a series of samples. So that makes sense. I think I'm going to rename data to signal. And if I remember correctly, there is another place where I have data. So I am going to rename this as well. So everywhere where I see data, I will rename this. And I could have done this globally, but I want to read all the instances to make sure that they make sense. All of them are going to go to signal instead. They are renamed to signal. But let's return to the circular buffer. And this is the second time we are implementing this actually. We are going to try to make this faster. We'll see if we can make it faster. And we are still testing this whole approach of having real objects. We'll see if that holds water and if that's fast enough. All right, so we have the size, which is necessary to wrap around the index. We have the index, and we have the signal, which is just the series of samples. Or whatever else the signal may be. The signal may be something like a gain reduction signal on a compressor, for instance. So that's the definition of the data structure, and this is how you allocate the data structure. You need to give it the size, the maximum size, and then I allocate the data structure, and then I store all the stuff that I need. Then when I push a sample, so I was calling this the datum, which is the singular of data, but I renamed the thing from data to signal, so I guess I should rename this as well. Is this the only case of datum? Yes. So let's think about this. I guess I'm going to call this like, if this is a signal, then what is this, like a frame or a sample? I'm hesitating to call it a sample because it's not necessarily just audio that you're going to put into a circular buffer. Signal element, item, I don't know, frame. I guess I'm going to call it frame. No, that name has a meaning already in the context of audio. Let's check real quick what the Juice people have. In case you don't know, Juice is like this standard framework for when you are developing VSTs and audio units. Then you can use this framework to develop your code once and publish it in all the different platforms, from VSTs to audio units and so forth. So let's see, they have something that is a delay line, which is similar to our circular buffer. And they call it a sample. So maybe we'll call this a sample as well, but they don't have a name for what I'm calling a signal. Yeah, all right, I'll go with sample. And as a user of this, you will know that you can use a CircularBuffer for other things that are not just necessarily the audio coming in, the samples, so to speak. All right, so this push thing works by getting the fields from the data structure that we are going to need. Then we add one to the index, and then, so I guess this is kind of a big deal because of the order. So we are moving ahead first, and then we are storing. I think we should do this the other way around, because think about it, the first time you start this, your index is 0. So I think that I should just store something in position 0. And then I'm going to increment the index and wrap it around if necessary. Or maybe not. Well, adding one to the index and wrapping it around is essential. That much we have to do. Now, it's just a matter of the order. Do I want the index to be the next position you're going to write to, or do I want it to be the position you just wrote to? I think I actually want it to be this way, because then when I'm getting something, I can just say that position 0 will have a position here. A position 0 is just the index, and that makes more sense to me. All right, so then we have the CircularBuffer index. We are updating it on the data structure. We don't need to update the signal because we have already done so. And we just return the sample for good measure in case you want to use the result of this. It's going to be the sample. All right, then to get something from the CircularBuffer, you need to give me the position. I guess I'm going to rename this to offset. And then, yeah, I'll have a base index and an offset based on that. That's all right. So you give me the CircularBuffer, I get the size, I get the index, and I get the signal. Then I subtract the offset, and then I compare. If I went over, I need to wrap it around, and then I get that part of the signal. Perfect. Then we can skip all of this. This is about filtering. We are not dealing with filters today. Then let's think about the RMS. In fact, here's an idea. Before I even mess with RMS, how about we just test the CircularBuffer by implementing an audio effect, a really simple one. It will be just simple delay using the CircularBuffer. How about that? That would be fun, wouldn't it? So this is the library, and this is me using the library. It is going to be a documentation, kind of a showcase of what the library can do. So let's implement a quick delay kind of thing here. All right, so this is something that you have to call to initialize the library. And then I have some filter situation that I'm not going to mess with, but I also have a CircularBuffer, and that will be CircularBuffer new. Let's say that we are going to store sRate samples. The sRate is a variable that comes with Reaper. It stands for sample rate. It's the number of samples in a second. So 48,000 in my case. And I don't need to do anything else here on the init block, but on the sample block, I am going to what am I going to do? I guess I'm not going to use the filter right now, so I'm just going to comment this out, and I will do a simple delay kind of thing. So I'm gonna get this CircularBuffer, and I'm going to push sample 0 into the CircularBuffer. And before I do that, I'll get a hold of this old sample, which is okay, so what I'm doing here is just getting a hold of the old sample. Then I push the new sample. And note how I have to give a negative index. And that's because when I am using get, well, when I'm defining get, when I'm implementing get, I am adding the offset. Well, I'm not, am I? I should, I think. Should be adding the offset to the index. And then it kind of translates to how many mathematical formulas are written, where you have like a signal and you query, let's say that X is a signal, and then you're querying from like 1 sample ago or 3 samples ago. That's the kind of formula that people write. So this kind of matches that style. So I get a hold of the old sample, I push the new sample in there, and then I'm going to say that both channels, left channel, right channel, sample 0 and 1, they are both equal to the old sample. But let me also maybe put the dry signal in there. So this is more like a proper delay kind of thing. Whatever, this is just for testing. So I am now going to load this effect into REAPER and we'll play around with it. So you can see that everything here is muted, so we will not hear the effect right away. And that's usually a good idea when you're developing effects, because if you do a mistake, a loud noise may come through. And this is the effect. Now let me run some audio through this. I think I'm going to use something like a tone. And then let's put an oscilloscope. Right after. So this is the signal with a delay, supposedly, and this is the signal without a delay. So it's not super crazy, it's not awesome, but it is increasing the amplitude. And that's because we did not divide this by 2. So maybe I'm going to divide this by 2, or maybe even better, I'll multiply this by half, which is supposedly faster. So there you go. I think it's working. It is still increasing the amplitude. That is kind of weird, isn't it? Maybe I have to reload the effect. Full compile reset. This should be latest code. There you go. It's not increasing the volume anymore, but it is delaying the signal. Now, I wonder what I could do to actually test this. Thinking if I should put it like on my microphone. You know what? It is working. We know it's working. Whatever. I'll just move on. So let's commit this. So our CircularBuffer is supposedly working. I could and I will rewrite some tests for this automated tests, unit tests. We had those for the previous incarnation of this library. I'm going to bring them back. For now, we kind of implemented a simple delay kind of thing. It works, whatever. Let's move on to RMS. So when calculating RMS, this is the implementation of RMS. And I think I'm going to extract some things from this. I'm going to do this to do it effectively. I'm going to extract this idea of a moving average from RMS, and then I'm going to implement RMS again. So a moving average is more of a mathematical thing. It is, I think a moving average is closer to the notion of a CircularBuffer in the sense that it's more like a data structure, mathematics kind of thing, as opposed to like a digital signal processing kind of thing, like a biquad filter. So I'll move that to here. I'll call this the moving average And I will probably want to be more specific because there are different kinds of moving averages. I think this is called a rectangular moving average. Is that what this is called? Moving average filters. Moving average filter, moving average filter. Let me go to the Wikipedia article for a moving average that I know the name of. Exponentially weighted moving average. Let's see if they have another name that I can use. This is not the Wikipedia article. Okay. Box filter. Bo is here. Hey, Bo. Great to have you. And thanks for your continued support. I really appreciate it. So you're giving me the name box filter simple moving average. Let's see. Simple variations include simple moving average. And that is our guy. Yes. So we'll have here the implementation of simple moving average. Well, let's borrow some of the ideas that we have already implemented for RMS and modify what we need to modify. So instead of calling it RMS, I am going to call it moving average simple. So I'm now using this idea of namespaces. I will have different kinds of moving averages the same way that I will have different kinds of filters. So there you have it. To initialize this moving average situation, of course, the moving average is going to be a data structure because I will need to keep stuff around, and I will need to know the window size. In this case, I don't need to know the sum of signal squares, I don't think. Well, I don't think it's called that, but I do need to know the current sum. I guess I'll just call this the sum. And then this is, I suppose, the signal that I'm averaging. Right, okay. That all makes sense to me. So the way that the moving average is going to work is you are going to tell me, I want the average of the last 100 samples. Your window size is 100. The sum is going to be the sum of the most recent 100 samples. And the signal is going to be literally the samples. So when you give me a new one, that's what the meaning of a moving average. If you give me a new sample, I am going to update this signal and I'm going to update the sum. That's the way this is going to work. It's usually shortened to SMA. Fair. I wonder if this name is like RMS in the sense that people know the thing by the initials better than they would know by their name. Let's see. We have a name for simple moving average, for cumulative moving average, weighted moving average, and then exponentially weighted moving average. I think it becomes I don't like having so many acronyms. RMS, I think, is so standard. You see that in REAPER, and you see it in many other places. So I think that RMS is a good initialism. It probably is more popular than root mean average. But for the moving average, I am not so sure. Do you know? Do you have like a taste on this? Do you think I should call this instead of this? If I should have, I think I should have a namespace for moving averages, but then instead of simple, I maybe could have SMA. I don't know. Let me know. Okay, so let's see. When this is the definition of the data structure. Now, how do you initialize one of these? You need to give me the window size. And okay, no problem, Bo. So the question is, there are things like RMS that are very standard. You see that acronym in Reaper and you see it in many places. So when I'm implementing RMS, I'm calling it RMS. But for the moving average, I am not sure if people are going to know the initialism, if they're going to know SMA, and then when I implement CMA and exponentially weighted moving average. So EWMA. I think that people may not know these names as well as they would know just this, if you know what I mean. So I'm asking you, what do you think? Do you think I should call it like this, or do you think I should go for like SMA over here because it is like a term of art? What's your feeling on that? What's your taste on that? That's the question. Okay, so when you want to initialize one of these moving average thingies, you need to give me the window size. That is going to create one of these moving average situations. And I don't think I want to call this variable that. I think that the name of the variable could be just the moving average. I don't need to put simple there. Like that. Same way that when I have a filter, I call it filter biquad. But when I am working with the filter, just call it a filter because in that context, you know what I mean. So I think I'm going to go with that. So let's see. You give me the moving average. I initialize one of the simple moving averages. And then for the window size, I store whatever you gave me. Then for the sum, I'm going to rely on the fact that it starts with a 0. And for the signal, I will need to store something there. So it is going to be something similar to this, I suppose. Oops, I replaced the wrong thing. Oh, but I think we should use the CircularBuffer to implement the simple moving average, because this signal is definitely a CircularBuffer. Right, okay. So RMS is one, Bo says, RMS is one thing. It measures the power of a signal and is more accurate description of a level. An average usually shows too low numbers, too low for a dynamic material. So call it RMS because that's the standard. Oh yeah, I understand the concept of a moving average and I understand the concept of RMS. My question is about the name only. If I should have a name that looks like this, or if I should have a name that looks like that. I think that this is better. But I could go for SMA maybe if you make a convincing case. But RMS is kind of a term of art, while SMA I don't think is as much term of art. Maybe it is. I don't know. Right. So instead of just having a memory thing here, I will use CircularBuffer. And then I am going to create a CircularBuffer of that size. So that's my initialization of a moving average thing. Now let's push a new sample into that. And why is this a signal? It shouldn't be. Oh, I think it's a mistake from below. Yeah, we are on the CircularBuffer, we are pushing a sample. All right. So to push into the moving average, I will need to get a hold of the moving average itself. Let's rename this variable. And then let's do the work of actually pushing this. It's not the signal that I want, it's the sample. So pushing into a moving average is similar to pushing into a circular buffer, except that it will keep track of the sum as well. Right, so let's go over this. And by the way, for people who are watching this and you are confused about what a moving average is and why we are computing the sum and keeping it around instead of just going with the formula that you see on the Wikipedia page, I mean, the intent is to implement this formula, and it's a simple average of just the samples coming in divided by the number of samples. But I guess that's what you would call an arithmetic average or an arithmetic mean. I don't know these names, but in any case, it's a simple thing that you just add and divide by the number of samples. Right, but we are doing it this way, keeping the sum around, and then we're going to play some tricks here to make it faster. I have a series of videos in which I explain RMS. Then RMS is a kind of a moving average. So I explained all of this in detail, and I even benchmark all these things to show how much slower it would be to actually implement this straight from the formula. Right, so let's push a new sample into the moving average. I will need to get a hold of the sum and the signal, and I don't need to compute the signal square. In fact, I think it would be the sample square for RMS, but not for the moving average. Right, so we get a hold of the sum, we get a hold of the signal, then we don't square the signal, then we say that the sum minus something. I think we'll also need the window size. And the window size is the first on the data structure, so I'll put it here. Oh, in fact, there is a better way of doing this, isn't there? On the CircularBuffer, we already have the notion of size. So all I gotta do is create another function that gets the size out of this data structure, and then I don't need to repeat myself when I'm doing the moving average. I would just rely on the CircularBuffer. Right, so let's do that. Circular, I am writing code behind my face. CircularBuffer get size, or maybe just size. Yeah, I mean, get size would be more like Java, and size alone is more like, I don't know, other languages. CircularBuffer. And then all I gotta do is, oh, in fact, I don't need this function. We learned that functions make things slower. So we'll not use a function. We are just going to use this to get a hold of the CircularBuffer size. All right, so let's do this. I'm not going to store the window size, so I don't need to do, just going to store the sum and the signal. Then in here, I don't need to store the window size, and I'm not storing the window size. Well, I am here. There you go. And this is going to store the window size implicitly. Right, great. And then when I want to push something, I will need the window size because I will need to do this bit where I go get the old sample that is going out. I need to get it. So let's see. The way I'm going to do this is I'm going to get a hold of the signal. And from there, I'm going to get a hold of the size. of that circular buffer. Then I am going to need the sum and the signal. I guess I'm going to put this last now because it's this derived field. And I already have the signal, so I can just do that. Perfect. Then for the sum, I'm going to subtract the sample that is old and it's going out. So I'm going to do that. And I'm going to add the sample that is coming in. Right. And then I am going to push, not the sum, I'm going to push the sample. I'm updating the sum, and then I'm going to update the signal. Great. And then I'm going to update the sum on the data structure for the next time. And I'm going to return not the signal, I'm going to return the sample. That's the same that we did over there. So when you're pushing a sample into a circular buffer, you get it back as a result. If you're pushing a sample into the moving average, you get the sample back as a result. Great. Then to get the current value of the moving average, you give me the moving average and I am not going to take the square root of anything. That's an RMS kind of thing to do. I'm going to get from the moving average the sum and divide by the window size, which is this is not how I retrieve the window size anymore. I have to do it with 2 indirections. So that may be too slow. We'll see. It's definitely long, but whatever. So this is, I think, a fair implementation. It's fairly short. It's not bad. Let's double check everything that is in here, commit and test, and then we'll do RMS. So this is the initialization of the data structure. You give me the window size. I'm going to return to you the moving average. I just initialize the data structure. No typos there. And then on the signal, I'm going to create a circular buffer of that size. Then to push into the moving average any given sample, I'm going to first retrieve those fields. Then the window size I'm just going to get from the signal. Then I subtract the old sample and I add the new sample. Then I push the new sample. Then I do this, which is going to update the sum in there and I return the sample. And to get, I just get the sum and divide by the window size. Maybe I should have local variables for this. For readability only. And I wonder if these variables that I'm introducing will make things slower, but I don't think they will. I hope they won't. I guess more or less what I'm saying is I would like to have these lines and then divide by the window size. Yeah, now because I extracted these variables, then this formula is very straightforward. Right, so let me catch up with what you all are saying and then I will test this commit and whatnot. So Bo is saying, isn't an exponential moving average based, hang in there, isn't an exponential moving average based on RMS less taxing on the CPU and memory? Okay. So if you do RMS, there are 2 ways of doing that. You can do the formula with the simple moving average like we are doing, or you can do an exponentially weighted moving average. And this is going to use way less memory because you don't need to store the signal. And I think it will be lighter on the CPU as well, if only because we are not going to store and fetch so much stuff from memory. So that is already a plus, but it is not as accurate. And I have a series of videos, 4 videos, and I implemented the exponential moving average, and it decays in a weird way. For some purposes, it may be okay, like if you're doing compressor. I found that for my auto mixer, it didn't work very well. I didn't like the result. In the original auto mixer in Reaper, there is an exponential moving average. That's how I learned about it in the first place. I just don't like the result. So I'm using RMS with this formula, and there are many plugins that do that, so it's not unheard of. And maybe all this memory stuff that I'm doing will slow things down. But if you do it with pseudo objects, it is fast enough. And you're just using 48,000 samples. Like if you want an RMS of 1 second, which is huge, usually you go for like 300 milliseconds. So what is 48,000 times 300 milliseconds? It's 14,000 samples. It's not a big deal. Plus, exponential moving average give a smoother signal than that is true. It is smoother. I just didn't like the result of it, but it is smoother in my experience. But I guess it's too smooth. For my auto mixer, that meant that the signal would not, when the person stopped speaking, the signal would not be quiet fast enough, and you would hear some of the noise. And the opposite would also be true. When you started speaking, you could hear the gain going up. All right, so let me commit this. And if everything here is right, when I do moving average of just the signal without RMS stuff, if I just do a moving average, we should hear some result. So let's do a moving average. Simple. And I guess in this case, it makes sense for me to namespace this, because when I am fleshing out this demonstration thing, it will have more moving averages. While in the implementation of these methods, just the name moving average is already explicit enough and specific enough. All right, so let's do a moving average, simple, new, of a size of maybe like S-rate. Why not? Or maybe S-rate times 0.3, which is 300 milliseconds. Maybe let's have a function that does this for us. So mathematical functions. Let's have some functions that convert stuff. So let's have a function called milliseconds to samples. Milliseconds. Am I writing milliseconds right? All right. And it's just milliseconds times S-rate times 0.001. Did I get it right? Let's see. Let's work through an example of this. So if I have like 300 milliseconds times 48,000 samples times 0.01, that looks correct to me, but let's do like maybe 500 milliseconds, which is half a second, and it should be half the amount of samples. Right. So 500 milliseconds. And why am I doing this in milliseconds? Because milliseconds are common when you are calibrating stuff. Milliseconds is a good unit of measurement, better than seconds, I think. There you go. So then I can, in here, just say milliseconds to samples, 300 milliseconds. So that's going to be my moving average, simple, window size. Then I'm going to comment out all of this stuff about the CircularBuffer. And I'm going to do moving average simple push into this simple moving average that I have going on, sample 0, and sample 0 equals sample 1 equals moving average simple get of the moving average simple. So in effect, I'm just outputting the signal that is the moving average of whatever is coming in. Let's see what happens. Okay, that sounds about right. It is a stable signal because we just have a sine wave coming in. But the litmus test is going to be to change the gain, and we should see the moving average changing, and we don't. We still see just the number 10. And actually, this number 10 does not make sense. Because we have numbers that are very low. We have numbers that are like 0.00001, whatever. And then a 10 coming out. That does not make me happy. Something is wrong. All right, I'm going to compute what I have. I'm going to read what you are writing, and then I'm going to try to fix this. My suspicion is that the math you got for the timing wasn't correct. I've never gotten it proper, so I wing the numbers till it sounds good. Yeah, I found the numbers that many people use, and I read some Stack Overflow answers. There are links for all these things in the video that I keep bringing up. I just couldn't get anything I liked either. Well, I guess you can make it sound good. I cannot, at least in that context. There are some other types of averaging that are even smoother and less phasey if you're interested. Yeah, I've even worked on a couple of novel ones myself. Great. I would love to hear about that and maybe include it in my library. I mean, for computing RMS, which is our goal today, doesn't really matter. You don't need other kinds of moving averages. I think that this is like so simple, so standard, everyone uses it, it's right, it's fine. But for something like a compressor where you are trying to smooth out the gain, it may be good to have something else as a moving average, because this something else may sound good. So I'm interested. What are we doing wrong? How do I even start? Let's start with this, because it's so simple. So I am just going to check that this computes the number of samples all right. And we learned that it's like forcing 400, right? The right amount. Oh, I find it so difficult to select text on this window because the cursor that shows up on the screen doesn't exactly match the text, whatever. So we see when I peek that it is 14,400. So that much is right. And let's just give it a 500 so we can see our good old 24,000. Great. So that is right. And then let's double check our variable stuff here if we don't have any typos or anything silly like that. So our moving average simple should be the argument here, and it should be the argument there, and that is all right. Then the function names must be right because otherwise REAPER would complain. And you can see some complaints here on the window, but now it doesn't complain, see? So that is not the mistake. And then let's see. Yeah, nothing here stands out. Cool stuff. The variable names all here. on their I can see like the enumerations, and they are all below everything else that I have on my demonstration effect. So I like the way that this is going to work out. Right, so it seems like our use of the moving average is correct. The issue must be on the implementation. Maybe something we can do is to write like a unit test kind of thing. So instead of pushing samples into the moving average, I am going to push some numbers that I know the average of. So if I have an average of let's say 3 numbers, let's go simple. The average between 2 numbers, and if I push the number 10 and then the number 20, and then I try to get that, that is not right. That is not the average between 10 and 20. Yeah, right. So now we have a small case that we can work with. Let us start by verifying that the stuff that we put in the CircularBuffer ended up in the CircularBuffer the right way. Let's have a debug 1, debug average, and a debug 2 variable as well. Then from the moving average simple, I should be able to fetch the signal, which is a CircularBuffer. From the CircularBuffer, I should be able to fetch the signal. And then from that, I should be able to get positions 0 and 1, and they should be 10 and 20. Right, let's try this out. Nope, they are all zeros. Huh. That is interesting. Let's see. I will have more debug variables. All right. Oh, so those are zeros as well. That is odd. Debug 1 was supposed to be 10. Let's go into... I wonder if I should like commit something, because I'm going to start messing with code harder here. So when I am doing the moving average push, should be just returning the sample. I'm not. I am not. Or something else is going on and I'm missing something. Oh, this doesn't look right. This address should not be 0. In fact, everything is 0? That cannot be right. There you go. I moved the playhead and now we see some values, and then it makes a lot more sense. So yeah, when I'm pushing stuff into the moving average, I get stuff back. So I get back 10 and I get back 20. But when I try to fetch it back, I get 10 and 20. All right, so maybe I messed up the indices, but I'm getting back the right values. Then the average is incorrect. But the average kind of looks like the address of the thing. So I probably just have a place where I'm treating an address like a number. And now I don't have any kind of memory safety. So that's what's going on. Oh, and the moving average is changing. That does not make sense. For instance, how are you getting a 3 here? We have a memory corruption, guys. We have a memory corruption. This is gonna be fun to track down. It can be like a typo anywhere that would be causing this. And I guess I kind of already went over all the strategies I have for debugging this. Now it's just doing it more and more. So let's think. I think that the data coming in is already wrong, let alone the average. The data coming in is already wrong. Let's check. So what could be going wrong? Well, could something be wrong in the CircularBuffer? Let's write a unit test for that. So I'm going to comment out everything I have going on my moving average, and we're going to debug the CircularBuffer. I mean, it kind of looked right by our simple delay kind of effect, but you can never be sure. So I'm going to push into the CircularBuffer. Again, I'm going to create a CircularBuffer of size 2. Hang in there. Is my size calculated correctly? Let's double check that. That is correct, yes. All right. Right, okay. So I have a CircularBuffer of two positions. I'm going to push into these 2 positions, the number 10 and the number 20. Just like that. And then we're going to try to fetch all this stuff from there. Fixing the indices so that debug 1 and debug 1 again are going to match, supposedly. Then I am going to go into the CircularBuffer directly. Right, okay, so I'm getting, oh, I don't need the dot symbol in this case. I'm just getting a hold of the CircularBuffer, going straight into the signal in there and trying to fetch it. Let's see if that gives us any reasonable output. Yes. Things are going into the buffer and out of the buffer in the right way. What if I write 10, 20, and 30? So debug 1 again, I'm not sure. So I rewrote the 30 on top of the 10, supposedly. So the debug 1 again becomes debug 3 again. Am I right? Yes, I write this, I write that, and then I overwrite the first one with the third one. So what was position 1 became position 3. Oh my god, I cannot even get my head straight around this. Oh, it's so hard. Let's see what comes out. So debug 1, 10, 20, and 30, that's fine. And then we have 20 and 30. Yeah, and I got the numbers wrong, but it makes sense. I have 20 and 30, and 10 is out. Great. So it seems like I'm very confident about the CircularBuffer at this point. I think the mistake really is in the moving average. Let's see. I guess I can comment this out. I'm going to comment out everything that is not essential. Then let's create a moving average of 2 positions and try the same test. When I am going through the moving average and trying to push stuff into the CircularBuffer, it does not come out correctly. It does, I'm seeing. Yeah, it comes out as a 3. So the memory corruption seems to be when I'm using the CircularBuffer in the moving average computation. Yikes. Let's double check everything that we have. Oh, that does not seem right. This is a variable that doesn't exist. I should be using this instead. It's missing a dot simple. That's a mistake already. Let's see if there are other ones of the same kind. So let's double check that all of our moving averages are followed by a simple. Right. No, that is not the only issue. But it was a mistake. So I'm going to commit this because it was a mistake. We caught one mistake. To push into the moving average a new sample, we need to update the sum and we need to update the signal and we just need the window size to be able to do this. Oh, this doesn't seem right. But never mind that. I think that we shouldn't go minus window size. I think we should go minus window size plus 1. And I feel like we are using this minus trick in other places, and these places may be wrong, but maybe it was just the RMS computation that was wrong. Okay, so a reason why I think I'm off by 1 here is that I start counting these indices by 0. So I should be doing minus window size plus 1. And then the sum is not going to affect the ability to get stuff out of the CircularBuffer. So let's see. Man, everything in here seems right to me. Oh, but maybe this mistake was affecting. It was, no, this is just getting, it's not setting anything. Yeah, so it's not overwriting memory in any place. So this will have no effect. And it's weird that the 10 again, the debug 1 again is getting the second variable. So it's off by 1 somewhere. Let's see if the test is right. Well, I am getting a hold of the signal. Getting distracted. Right. Okay, so I have this moving average and I'm trying to get the signal out of the moving average. The signal is supposed to be a circular buffer. And from the circular buffer, it's just a chunk of memory and I index from that. I'll be right back. I was getting distracted because I kept hearing this person on the door who was talking to my wife, trying to sell her some internet plan or whatever. Oh man, so annoying. Okay, we should be back to our headspace here. Right, so I'm trying to push stuff into the moving average. It's not coming out. It's not coming out. So I'm pushing stuff into the moving average and it's corrupting the memory somehow. So how about we go and try to set stuff into the memory location directly? Well, that's going to be a silly test, but I think I'm going to do it anyway. I'm going to keep these two lines around. And I'm just going to store stuff in there and get it out of there. Okay, that makes sense. I am putting stuff there and I can get it out of there. Excellent. That's a good first step. Now, let's try to use this as a circular buffer directly. So we are more or less repeating this experiment, but now with the circular buffer that is embedded in the moving average. And now it makes sense to have the debug variable again. All right, so it does make sense when I'm using the circular buffer that is embedded in the moving average, it is getting in and out of there correctly. Next, there is a problem when I'm using push to go through that. So when I go through the push function, the circular buffer is getting corrupted. Let us return to the call to push. And let's go to push and let us just use. Hang in there. Where in push? I should be pushing into this. Oh, this is the circular buffer. Here I should be pushing into this the signal. I am. So I'm going to comment out everything that does not have to do with pushing. So I'm just exactly mimicking what I was doing over here. Am I right? Do I have the same variable name and everything? Yes. So I'm getting the signal out. Then I am pushing stuff into the CircularBuffer, which is the signal. Pushing the sample there, the sample that came in. Second argument. All right. Everything is in place. I'm just going through another function call to do this. It shouldn't be wrong. It shouldn't be. It is not. It is not wrong. Okay. That's good progress. Let's just get a hold of the sum. If we get a hold of the sum, we don't change anything. We shouldn't be corrupting memory or anything. We're not. Then let's just fetch the window size. Fetching the window size. No big deal. Not corrupting memory because I'm not even changing anything. Oh, my caps lock is on. Oh, no. Cancel. Save. Okay. Full compile reset. Everything is still alright. Then, what if I am computing the sum? I am getting stuff from the CircularBuffer and everything, but I'm not pushing anything. I'm not changing anything. Everything is still alright. What if I return the sample? Everything seems to be still alright. I'm going to just play the project real quick again, just to make sure that I'm resetting all the variables alright. Yeah, it seems to be okay. Then, I have to compute the sum. Or I have to store the sum. And that's when things are going to go south, I think. Yes, now the debug 2 again is 0, so that is a mistake. But why? Makes no sense. Man, this is a difficult bug. And I'm sure it's gonna be like a typo somewhere. Oh man. This is annoying. Here's another thing I want to do. I think that the line that is to blame is this line, but it makes no sense because this line is correct. It is so correct. There is nothing wrong about this line. I'm fetching the sum using this. Just moving average and add this index. So that's the right index. This line is correct. It is so correct, yet it is wrong. And I have no idea why. But without this line, I'm not updating the sum. And when I try to get the average of that, it should be an average of a bunch of zeros. So I should get an average of 0. And I don't think I am getting an average of 0. Yeah, so check out this debug average variable. I think it was all over the place. I think I saw it going all over the place. See, that makes no sense. I'm averaging a bunch of zeros and I'm getting 12 back. And I'm getting 32 back. And this goes up as I play. Nasty bug, man. Memory is hard. Let's see what could be going wrong. Let's have a debug underscore variable, which is our sum. It should be 0. It's 24. What the hell? I mean, what is even going on? What else do we have in memory here? I don't think we have much, but we do have the bike wet filter. So let's comment out this as well. Let's comment, oh, so this is necessary because this is the moving average that we are working with, and everything else is commented out, okay? We're not exercising anything else. And we have a number there. At least the average is half of 7, so the average is getting the window size correctly, and it is computing the average correctly. If I have an average of 3 numbers, no, not there, an average of 3 numbers there. Then what is 7 divided by 3? All of that is working. So getting the size of the CircularBuffer, getting the CircularBuffer, all of that is correct. And even these numbers are right now. The sum is incorrect. Who's touching the sum? Oh man, oh man, oh man. Let me go back to 2, just match everything else. And then let's get a hold of the sum as we go. So I have the moving average simple. I can just fetch the sum. Like that. And sum 1. Before we push anything, then after we have pushed something. Oh, and another thing I should be doing, all of these stats, they should not be on the sample because sample runs in a loop. I want this to run in the init block. In fact, the same is true of these tests. I'm going to move them up as well. And then in the sample block, we don't do anything. That's perfect. So now we have sum 1 and then sum 2. Let's maybe just have sum 0, 1, and 2. Right, and this is only going to run once. Sum 0 already starts with a 7 in there. That is crazy. Is the memory not zeroed out to begin with? Or am I looking at places in memory that I don't think I am? Getting different values, it seems like it's junk. Man. Everything up to this point leads me to believe that the memory is zeroed out, and I can zero it out explicitly. I can also check the documentation just to make sure. Now I'm doubting this assumption that the memory is 0 to begin with. All memory and variables are 0 on load. Oh, and if no serialized block is defined, then all memory and variables will be re-zeroed. But in my case, I do have a serialized block. What if I don't have a serialized block? No, the serialized block is not the issue. It remains. What the hell is that 7 in memory? It makes no sense. Do I have to like play the playhead? Pull compile reset, playing the playhead. I think that this is going to remain a mystery, guys. I don't think I will be able to go through this. I may have to work on this off stream or whatever. This is going to take me like... this is already taking me so long. I'm not even able to do the RMS because I cannot get the moving average right. Disappointing. What could be going wrong? What is wrong in memory? What is in memory at this position that is making all of this go out of whack? But only for the sum, not for the signal. And the signal is a lot more fragile because it needs to go through the CircularBuffer situation. No. The sum is supposed to be the easy part. Well, what if I am explicit and I zero this out? Does that help? What a freaking ghost! Where is the 7 coming from? Do I have any other variable whose value is 7? I do not. Where the hell is that 7 coming from? What the hell? Memory is initialized at 0. Reaper is not to blame. JSFX is not to blame. I simply have a bug here and I cannot figure it out for the life of me. Maybe I should move on to something else and get back to this later. Well, but this line is right. But with this line, so there's something weird about this sum situation, right? This index is supposed to be 0, so let's check that it is 0. Moving average simple struct sum. Well, hanging there. That is not right. One of these is supposed to be 0, the other is supposed to be 1. Bo says, sorry I can help, but the stupidest of all the stupid advice, reboot Reaper? No, I think that it's not the case. I think I have a bug in my code, really. It must be. So this line is right. I am bringing it back, okay? How about we don't do anything? We don't even instantiate anything, okay? I'm just going to comment out everything. In my demonstration, I'm only initializing. Then I'm not doing anything. Everything is commented out, except for this line. And I don't think that the serialized block is to blame, so I'll bring it back, but whatever. No, I'm not going to bring it back because serialize has some side effects with respect to memory, so nothing. There's nothing. My code doesn't do anything. Let's full compile reset. You can see everything is commented out. I'm not doing anything. Right. So let's check what is this. This moving average simple struct. Oh, hanging there. I never ran this function. Oh, I forgot to put it here. So it is CircularBuffer moving average, then filter, then RMS. Okay. And that's all the functions that we have, right? We have CircularBuffer moving average, filter, and RMS. CircularBuffer moving average, filter, and RMS. Okay, so because I didn't have that line there, my initialization was never defined in the data structure, and then all of these values were 0, and then they kept overwriting one another. Now, I cannot tell you where that 7 was coming from, but I can tell you that this was a major bug. So let's see if that helps. Oh, hang on, where? There is an error in line 414. There's an error in line 414. Let's go to line 414. Okay, I forgot a semicolon there. Shout out to Aria. Okay, so everything is all right. And we have now the indices there. Great. So with that, we can uncomment this test, which I think is just uncommenting all of this. And then the average, I brought back the code that is computing the average. So the average between 10 and 20 is 15. And 30 is the sum. I do have a debug variable here. I can remove it. So the moving average is right. Okay, a light at the end of the tunnel. Man, that was excruciating. So now that I have the sum going on, all of these tests have passed now. I'm going to keep them around because I think I will transform this into some unit tests in the future. All right, but whatever. For now, we can just bring back the thing that is computing the moving average of the last 300 milliseconds. Let's see what happens now. It's kind of difficult for me to tell what's going on because the numbers are going to be so small, aren't they? Yeah, these are like numbers between 0 and... So maybe what I should do is get the dB out of this number, because the number is going to be so small. But we can check it. We can have like a debug variable here, and it should not be 0. It should be very close to 0 though. It is 0 only. It's alternating between 0 and -0, which it is weird. Okay. So that 0 makes sense to me. And all of these small numbers make sense to me. But this 0 -0 situation does not make sense to me. So I guess what I'm going to do is I'm going to convert this. So I will implement another one of those auxiliary mathematical functions that I guess I'll have a section for this, like conversions. Because they are not really mathematical functions. They are like unit conversions. So I already have milliseconds to samples. I probably need samples to milliseconds. I'm so proud that we nailed the bug on the stream instead of me having to do it off stream. So what we need is an amplitude to dB. And I'll call this the amplitude. And to go from amplitude to dB, we need to take the log base 10 of the amplitude multiplied by 20. And then over here, I will have a moving average of the samples, all right. But I am going to get there. I'm going to output them in dB. Oh, and then REAPER is auto-muting my track because it gets very loud. Because this number is in dB. So instead, I will have a slider. that I will call moving average slider dB, whatever. Doesn't really matter. I'm going to start at 0, go from 0 to 0 with a step of 0, moving average in dB. And then I will set this to the moving average in dB. I am not updating the slider. What could be going wrong? Oh, today is a hard day. I'm having a hard time today. So this number is not changing. But I am changing it there. But if I have a range that is wrong, maybe let's go from 200 to 200 on steps of 1. Whatever, I just want to see this. Can I see this? All right, so something is happening now. At least that is going on. This moving average doesn't look right to me. Does it make sense? It does not make sense. I was expecting that the output in dB is minus 13, so I was expecting to see minus 13 here. That is incorrect. This is annoying. Is my computation of amplitude to dB correct? I'm just now looking for any plugin that does anything with dB that is going to compute the log 10 and whatnot. I cannot find a single plugin that does that. Can find myself. Oh, there you go. So amplitude to dB. That's my own plugin from a video way back. Just to make sure. 20 times. Oh, I need to take the absolute value of the amplitude. That could be throwing things off. Because my amplitude is negative and the logarithm of negative numbers is not defined. Right, so that's a bug. All right. Okay, and now I see some signal in there. Okay, okay. Oh, but I'm not changing the signal now, so that's kind of expected. Right, full compile reset. Yeah, this is all over the place. All right, I will have to say goodbye with this low note. Today was not a good day for us, was it? Nothing worked and we didn't get the RMS to... We didn't even get to work on the RMS, let alone get it to function correctly. Whatever. It is what it is. Sometimes it is like this. I think I will try to do this off stream and find out whatever bug is going on here, because just watching me chase bugs and get annoyed is not entertaining. Tomorrow I'll be back at the same time. Hopefully things will work by then. The whole moving average situation will be done by then, hopefully. And then we will get to finish RMS, or maybe I will even finish RMS because we kind of know what's going on, and then we can move on to something else more interesting. I don't know. What a bad day. It was not a good day. But tomorrow will be better. We just have to keep going. Thanks for watching this, and I see you again tomorrow. And thank you both for being here and watching me be grumpy and make a fool of myself. Sometimes it is like that. Yeah, all right. See you tomorrow. Bye.